Welcome students. In this part I am going to start the trends in electron gain enthalpy and electronegativity in a period and in a group. As in our previous video we have discussed the trends in ionization enthalpy. So today we will discuss the trends in electron gain enthalpy and electronegativity. So let's start. So first is electron gain enthalpy. Electron gain enthalpy, it is the energy. Enthalpy means energy. It is the energy released when electron is added to an isolated gaseous atom. When we are adding an electron to an isolated gaseous atom, that at that time the energy which is released, that energy is known as electron gain enthalpy. And you can see by the image this reaction also. Here this A is an gaseous atom. It is an isolated gaseous atom, and as it is gaining one electron, it's getting converted into an anion, A negative, in the gaseous state, and at that time the amount of energy released on gaining this electron, on adding this electron, the amount of energy released, that amount of energy is known as electron gain enthalpy. It is represented by delta Eg H, where H is for enthalpy and Eg stands for electron gain, H stands for enthalpy. So it is the electron gain enthalpy, and the unit for electron gain enthalpy will be kilojoule per mole. For many elements, when the electron is added to an atom, since energy is getting released, therefore the electron gain enthalpy is always negative. For many of the atoms, since the gain of electron, on gaining an electron, the energy becomes negative or the energy releases, it means the enthalpy value or the electron gain enthalpy value will be negative. क्योंकि अगर इलेक्ट्रॉन गेन हो रहा है तो एनर्जी रिलीज हो रही है गेन के टाइम में, तो इलेक्ट्रॉन गेन एंथैल्पी की वैल्यू हमेशा नेगेटिव होगी फॉर मेनी ऑफ द एटम्स. और कहीं अगर कोई चेंजेस हैं सो दे विल कम इन द डिफरेंट कंडीशंस. अगर कहीं पे कोई चेंजेस होंगे इलेक्ट्रॉन गेन एंथैल्पी में, अदरवाइज द वैल्यू ऑफ इलेक्ट्रॉन गेन एंथैल्पी will be negative because of the release of energy takes place on adding an electron to it. Here, if an atom has more tendency to accept an electron, large energy will be released, and it means the electron gain enthalpy will be highly negative. अगर कोई atom उसकी tendency है वो मोर अमाउंट में इलेक्ट्रॉन को एक्सेप्ट करे, तो उतने ही ज़्यादा अमाउंट में एनर्जी रिलीज होगी. जितने अमाउंट में इलेक्ट्रॉन एक्सेप्ट करेगा उतने ही अमाउंट में उसकी एनर्जी रिलीज होगी. अगर ज़्यादा अमाउंट में इलेक्ट्रॉन उसने एक्सेप्ट करे, मोर टेंडेंसी टू एक्सेप्ट इलेक्ट्रॉन, सो द लार्ज एनर्जी विल बी रिलीज्ड. एंड इसका मीनिंग है, इट मीन्स कि इलेक्ट्रॉन गेन एंथैल्पी की वैल्यू विल बी हाईली निगेटिव. एज आई ऑलरेडी टोल्ड यू, इलेक्ट्रॉन गेन एंथैल्पी की वैल्यू नेगेटिव होती है, बट अगर वो लार्ज अमाउंट में इलेक्ट्रॉन एक्सेप्ट कर रहे हैं तो लार्ज एनर्जी रिलीज होगी. इट मीन्स हाईली नेगेटिव वैल्यू ऑफ इलेक्ट्रॉन गेन एंथैल्पी ऑफ will be of that atom. Similarly, if an atom has less tendency to accept or to hold the electron, so the amount of energy released will also be small, and at that time it is leading to a small negative value of electron gain enthalpy. अगर ऐसी कंडीशन है कि इलेक्ट्रॉन जो एक्सेप्ट हो कर रहा है कोई भी एटम, वो इलेक्ट्रॉन गेन करने की टेंडेंसी उसकी कम है, या उसको इलेक्ट्रॉन को होल्ड करने की किसी भी एटम की टेंडेंसी कम है, तो अमाउंट ऑफ एनर्जी जो रिलीज होगी वो भी एक लेसर अमाउंट में रिलीज होगा. सो ड्यू टू दिस द वैल्यू ऑफ इलेक्ट्रॉन गेन एंथैल्पी बिकम स्मॉल नेगेटिव. Come to the factors. Electron gain enthalpy depends upon the following factors. First factor is size of the atom. With increase in the size of the atom, electron gain enthalpy becomes less negative. As the size of the atom gets increases, it means the holding capacity of electron with the nucleus it gets decreases, and at that capacity gets decreases because of increase in the size of the atom, the electron gain enthalpy for any of the atom it becomes less negative, because at that time the release of energy will be less, so the value of electron gain enthalpy will be less negative. Similarly, it depends upon nuclear charge. Nuclear charge is the attraction of electron with the nucleus. So electron gain enthalpy become more negative as the nuclear charge increases. As the electrons are more attracted with the nucleus, it means nuclear charge increases, And as the nuclear charge increases, it means an atom has a tendency to accept more electrons, because electrons are attracting towards the nucleus because nuclear charge increases. So at that time, the amount of energy which is released, it is high, and due to this the value of electron gain enthalpy become more negative. Similarly, the next factor is electronic configuration. The elements having stable electronic configurations like half-filled or completely filled valency subshells show very small tendency to accept additional electron, and therefore the electron gain enthalpies are less negative. जितना भी हमारा स्टेबल इलेक्ट्रॉनिक कॉन्फ़िगरेशन होगा, स्टेबल इलेक्ट्रॉनिक कॉन्फ़िगरेशन लाइक इन केस ऑफ हाफ फिल्ड सबशेल और इन केस ऑफ कंप्लीटली फिल्ड वैलेंसी सबशेल, अगर ऐसी कोई कंडीशन है, बिकॉज वो ऑलरेडी स्टेबल अपना एक कॉन्फ़िगरेशन अटेंड कर चुके होते हैं, सो उन्हें कोई भी एक एक्स्ट्रा इलेक्ट्रॉन ऐड करने की उनकी अब जो टेंडेंसी होती है अनदर इलेक्ट्रॉन को गेन करने की, वो टेंडेंसी बहुत कम होती है, बहुत स्मॉल अमाउंट में वो इलेक्ट्रॉन को गेन करेंगे. इफ दे आर गेनिंग द इलेक्ट्रॉन विथ वेरी स्मॉल टेंडेंसी, then the amount of energy release will also be very small, and as the amount of energy release is small, it means the electron gain enthalpy are less negative. Now let us check the variation along a period. So on moving left to right in a period, in general, electron gain enthalpy becomes more negative. When we move left to right in a period, then the value of electron gain enthalpy becomes more negative. So the reason behind this, it is due to the size of the atom, because the size of the atom decreases and the nuclear charge increases as we move left to right in a period, and which results in greater attraction for the incoming electron, and therefore the electron gain enthalpy becomes more negative because more amount of energy will be released because of the gain of the electron on moving left to right in a period. Now let's check the variation in a group. On moving down the group, in general, electron gain enthalpy becomes less negative. And the reason behind this, again, as we move down the group, the value of electron gain enthalpy, or the value of atomic size, first of all, the value of the atomic size gets increases when we move down the group, and on increase in atomic size, as I already discussed, that electron gain enthalpy depends upon atomic size, and as the atomic size increases, the value of electron gain enthalpy becomes less negative, or it gets decreases, because the holding capacity of electron with the nucleus, it gets decreases, and due to this the value of electron gain enthalpy becomes less negative because less amount of energy is released on moving down the group. So the value becomes electron gain enthalpy have less negative value. Now one more thing, halogens have the highest negative electron gain enthalpy among the periodic elements. Halogens, group 17 elements, they have a highest negative electron gain enthalpy among the periodic elements. Now why this is so? As the valency shell of halogen are, a valency shell electron in halogen are 7, and they have a very strong tendency to accept an additional electron, and their electron gain enthalpies are highly negative. Because we know that जो वैलेंसी शेल इलेक्ट्रॉन है, आउटर मोस्ट शेल में जो हेलोजन ग्रुप 17 के एलिमेंट्स के जो इलेक्ट्रॉन है वो है 7, और उन्हें अपना ऑक्टेट कंप्लीट करने के लिए उन्हें केवल एक ही इलेक्ट्रॉन की रिक्वायरमेंट है. तो जैसे ही वो अपना एक इलेक्ट्रॉन इजीली गेन करते हैं, अगर क्योंकि उन्हें एक ही इलेक्ट्रॉन की रिक्वायरमेंट है अपना ऑक्टेट कंप्लीट करने के लिए, एंड एज सून एज दे completed their octet, they gets converted into the noble electronic configuration, noble gas electronic configuration, or they attain the electronic configuration of noble gases which are of group 18. So what happens, they in their valency shell they have only 7 electrons, and they require only 1 electron to complete their octet. So they have a strong tendency to accept that additional electron, and due to that strong tendency to accept the additional electron, it means they have a good holding capacity of the electron, and as they have a good holding capacity of the electron, it means the electron gain enthalpies will be very high. And we know that the value of if I am talking about high electron gain enthalpy, it means the value should be in highly negative form, because at that time on adding the electron, energy is releasing, and as the energy releases, the value becomes negative in that case. So the electron gain enthalpies for halogene, it is highest negative because they require only one electron and they gain one electron, and they gain that electron with a very strong tendencies. That's why halogen have highest negative electron gain enthalpy among the periodic elements. Next is electron gain enthalpy values of noble gases are positive. Now why it is so? As noble gases have stable electronic configuration, they have NH2NP6 electronic configuration, their octet is complete, and they have no tendency to take electrons, and as they have no tendency to take any electron, it means the value of electron gain enthalpy becomes positive, and the electron which will be added to the noble gases, that will enter to the different shell, now that will enter to the higher shell, not in the same shell, that will enter to the higher shell. It means the value of electron gain enthalpy for noble gases, it becomes positive due to their stable electronic configuration. Similarly, electron gain enthalpy values of beryllium, magnesium, nitrogen and phosphorus are almost zero. Now why this is so? It is due to the extra stability of completely filled 2s and 3s orbital in beryllium. As we noted, the electronic configuration of beryllium is 1:2s2. Its valency shell has 2s2 completely filled orbital, and similarly in case of magnesium, the valency shell electronic configuration is 3s2 for magnesium, because the electronic configuration of magnesium is 1:2s2 3s2. So the valency shell electronic configuration for magnesium comes to be 3s2. It means s orbital is completely filled here in case of beryllium and magnesium. So they both attain the stability because completely filled and half filled orbital have a stable nature, or they are stable in nature. So beryllium and magnesium, due to their completely filled or s orbitals, they attain extra stability. And similarly in case of half filled, in case of phosphorus and nitrogen, they have half filled 2p and 3p orbitals. In case of nitrogen, the valency electron is 2p3, half filled 2p3. P orbital is half filled because p has maximum 6 electron, and here in nitrogen there are only 3 electrons, so it is half filled now. And similarly in case of phosphorus, it has 3p3 valency electron. Now what will happen? The configuration, now due to this configuration, stable configuration of half filled p of nitrogen and phosphorus and completely filled s orbital of beryllium and magnesium, this configuration shows a little tendency to gain any electron, and hence their electron gain enthalpies are very low or almost zero. यही एक रीजन है क्योंकि उन दोनों का जो इलेक्ट्रॉनिक कॉन्फ़िगरेशन है बेरिलियम एंड मैग्नीशियम में कंप्लीटली फिल्ड s ऑर्बिटल है वैलेंसी शेल में, एंड नाइट्रोजन एंड फास्फोरस में हाफ फिल्ड p ऑर्बिटल है वैलेंसी शेल में. तो ये जो कंप्लीटली फिल्ड एंड हाफ फिल्ड ऑर्बिटल होते हैं, दे अटेन देयर स्टेबिलिटी, एंड ड्यू टू दिस स्टेबिलिटी रीजन ये अब कोई भी इलेक्ट्रॉन को गेन करने की जो टेंडेंसी इनके अंदर है वो बहुत कम है, एंड ड्यू टू दैट लो टेंडेंसी टू गेन इलेक्ट्रॉन, द इलेक्ट्रॉन गेन एंथैल्पीज are very low, or it is almost zero as well. Next is electronegativity. It is the tendency of an atom to attract the shared pair of electrons towards itself in a covalent bond is known as electronegativity. Simply, electronegativity means when an atom attracts a shared pair of electrons towards itself. When an atom linked with a covalent bond with another atom, and in between the two atoms, one atom has a tendency to accept the shared electron pair towards itself. So that tendency of an atom is known as electronegativity. Suppose I have two atoms A and atom B, and they are linked together by a covalent bond by the sharing of one electron of each, and they forms a covalent bond. Now if atom B has a tendency to accept this shared pair of electron which they shares in between them, and it has a tendency to accept that electron pair towards itself. So it means atom B will have the highest electronegative nature. So this is the tendency when any atom gains an electron or attract a shared pair of electron from the another atom. That tendency is known as electronegativity. This can also be seen by an example. Suppose दो टीम है डिफरेंट, एक टीम A है और एक टीम B है, और वो एक गेम प्ले कर रहे हैं और उस गेम में उन्होंने एक रोप को पुल करना है. सपोज टीम B के पास ज़्यादा प्लेयर्स हैं, तो वो जिस रोप को वो पुल कर रहे हैं, तो उनको उस रोप को पुल करने की टेंडेंसी टीम B के मेंबर्स के पास ज़्यादा होगी एज कम्पेयर टू टीम A. सो अगर वो टीम B के मेंबर्स अगर वो रोप को अपनी साइड पुल कर लेते हैं, जो भी उन्होंने एक रोप शेयर करी हुई है दो टीम्स के बीच में, अगर वो पूरी की पूरी रोप टीम बी के मेंबर्स अपनी साइड को शेयर कर लेंगे, सो इट मीन्स दैट टीम बी विल बी मोर इलेक्ट्रोनेगेटिव, क्योंकि वो सारे का सारा इलेक्ट्रॉन पेयर्स अपनी साइड को गेन कर रहा है या अपनी साइड को अट्रैक्ट कर रहा है. सो दैट मीन्स that atom which shares the electron, which attract the shared electron pair towards itself, that will be more electronegative, and the atom from which the electron pairs or the shared electron pairs being attracted by the another atom, that atom is known as electropositive atom. Now let's check the variation of electronegativity in a period and in a group. So variation along a period, electronegativity generally increases on moving across a period, because as we move left to right in a period, we know that atomic size gets decreases, so due to which electronegativity value will get increases on moving left to right in a period. And now the variation down a group, what happens with electronegativity? Electronegativity generally decreases from top to bottom in a group, as we know that from top to bottom atomic size increases and the attraction of electron with the nucleus gets decreases, and due to which electronegativity gets decreases as we move down the group, or we move from top to bottom in a group. Now let's check the difference between electron gain enthalpy and electronegativity. So the first difference is electron gain enthalpy. It is the tendency of an isolated gaseous atom to attract an electron, and whereas electronegativity, it is the tendency of an atom in a molecule to attract the shared pair of electrons. इलेक्ट्रॉन गेन एंथैल्पी तो किसी एक एटम की, एक आइसोलेटेड गैशियस एटम की एक ऐसी टेंडेंसी है कि वो एक इलेक्ट्रॉन को अट्रैक्ट करे. वहीं पे इलेक्ट्रोनेगेटिविटी एक एटम की ऐसी टेंडेंसी है कि वो शेयर्ड पेयर ऑफ इलेक्ट्रॉन्स को अपनी साइड अट्रैक्ट करता है किसी एक मॉलिक्यूल से. इलेक्ट्रॉन गेन एंथैल्पी कैन एक्सपेरिमेंटली बी मेजर्ड. Electronegativity cannot be measured experimentally. It is a relative number. इलेक्ट्रोनेगेटिविटी को हम एक्सपेरिमेंटली मेजर नहीं कर सकते. इलेक्ट्रोनेगेटिविटी को फाइंड आउट करने के लिए एक स्केल डिस्कवर है, एंड दैट स्केल इज नोन एज पॉलिंग्स स्केल. उस स्केल में ही इलेक्ट्रोनेगेटिविटी की कुछ रिलेटिव वैल्यूज हैं, एंड वो जो वैल्यूज हैं वो एक नंबर में उनकी वैल्यूज गिवन है. हम उसे एक्सपेरिमेंटली डिटरमाइन नहीं कर सकते. उनकी एक फिक्स वैल्यू नंबर्स में गिवन है इलेक्ट्रोनेगेटिविटी के केस में. Second, electron gain enthalpy has a unit and it is kilojoule per mole. It has a unit and it is kilojoule per mole. But electronegativity has no units. There are only scales for the comparison. Similarly, electron gain enthalpy, it is the property of isolated atoms. It is important. Electron gain enthalpy is the property of isolated atoms. Whereas electronegativity, it is the property of bonded atom. When atoms are present in their free state, in their isolated state, so that property can be explained by electron gain enthalpy. क्योंकि वही एटम एक इलेक्ट्रॉन को गेन कर रहा है, तो उस प्रॉपर्टी को हम बोलते हैं इलेक्ट्रॉन गेन एंथैल्पी. वहीं पे इलेक्ट्रोनेगेटिविटी वो प्रॉपर्टी है जो बॉन्डेड एटम की प्रॉपर्टी को दिखाते हैं. मतलब एक मॉलिक्यूल जब बन गया तो उस बॉन्डेड एटम की जो प्रॉपर्टी होगी दैट कैन बी शोन बाय इलेक्ट्रोनेगेटिविटी वैल्यू. Now I have some practice questions. So do these questions. Question first, among the elements boron, aluminium, carbon and silicon, which has the most negative electron gain enthalpy? Consider the elements boron, carbon, nitrogen, fluorine. The correct order of their non-metallic character is, four options are given and you have to choose the correct option which is showing the correct order for non-metallic character of these elements. Question third, the electron gain enthalpy values of halogens become more negative in order, and the order is given and you have to comment on this statement. Question 4, the radius of Na positive cation is less than that of Na sodium atom. Why? Explain. You have to explain this and do these questions, and you can answer the questions in comment box also. So thank you. Keep watching.